Interstellar object observed from Earth, currently racing through our solar system. Now, astronomers have captured that moment live, streaming in real time.
Something is moving through our solar system right now, and it is unlike anything we have ever seen before. Astronomers first caught it on July 1st, 2025. A gigantic object is tearing through space at more than 50 kilometers per second. Officially, it has been labeled a comet. Unofficially, rumor has it that it could be alien technology.
Aliens paying us a visit from another star system? What's up with that?
The next guest, Harvard astrophysicist Avi Loeb, has suggested the 3-Eye Atlas is actually some type of alien technology sent here from another solar system.
3-Eye Atlas's pulses, metallic radar echoes, and the strange escorts around Mars prove that it is not a natural comet. And if its course shifts even slightly, Mars is in the firing line.
Glare taking over our window to see this interstellar visitor from Earth is closing fast. Meanwhile, Mars is about to get a front row seat coming up on the cosmic calendar, October 3rd.
It will be a strike so big that it will release more energy than every nuclear weapon on Earth combined. So, if that's really dangerous, why isn't anyone doing anything? The government is running silent simulations, preparing for a worst-case scenario, but to the public, they swear it isn't real. This eye, and the more you get to know about it, the more it feels less like something huge is going to happen. It all began on the 1st of July 2025, when an automated sky survey in Chile flashed a new object onto its screens. Within hours, it was logged as an interstellar comet, the third ever found after Oumuamua and Borisov. The name it was given was 3-Eye Atlas. NASA didn't raise any alarms at that time. You were just told that they have found an interstellar object. What you weren't told is how much NASA is panicking right now. Barely a month later, on August 7th, a secure NASA server found a trajectory anomaly. It detected non-gravitational residuals. It means the object was not just falling through the solar system, something was pushing it. 3-Eye Atlas is moving at speeds that break expectations. One report put it at 54 kilometers per second. Another leak said 87 kilometers per second relative to the Sunday. To put that in plain terms, it covers the Earth-Moon distance in 80 minutes. Every hour, it crosses 4 times the distance between Earth and Mars's moons. At those speeds, even a small nudge changes everything. Analysts inside NASA calculated that a change of just 10 kilometers per second could swing the object from a near miss to a direct impact on Mars. That is the razor's edge we are talking about. And what kind of object are we even dealing with? Estimates put the mass at around 10 billion tons. The core alone may be 400 meters wide. Some reports even stretch that to 1,300 feet. The whole thing is estimated to have a diameter of 20 to 40 kilometers. To put that in perspective, imagine hundreds of Empire State Buildings in weight, or the whole city of San Francisco, flying faster than anything else humanity has ever tracked.
Just jump in with the possible size of this thing, like 20 to 40 kilometer diameter. That's massive. That is bigger than, I don't know, like city size, maybe like San Francisco or something.
A rock like that slamming into Mars would release the energy of about 2 million megatons of TNT. For comparison, the largest nuclear bomb ever tested on Earth was Tsar Bomba, and it was 50 megatons. This is 40,000 times bigger. The crater would be about 60 kilometers wide and 5 kilometers deep, and the dust storm could wrap the planet. And that was not the only thing strange about it. The way 3-Eye Atlas was venting gas defied the textbook rules. Comets vent when sunlight hits fresh ice. They blast out plumes of gas. It's messy and unpredictable. But 3-Eye Atlas didn't vent like a comet. On August 14th, the Mars Reconnaissance Orbiter caught something shocking. The object doubled in brightness. Ultraviolet sensors spiked. Spectroscopy from Gemini South in Chile confirmed that massive bursts of carbon dioxide were shooting out. But not randomly. These bursts fired every 17 minutes. Over days, the pulses never drifted off schedule. Even more alarming was that each jet was aligned with Mars's orbital plane. That means every burst was pushing 3-Eye Atlas closer to the red planet's path. By September 19th, models showed those tiny pulses could reduce the safe distance from nearly 2 million kilometers down to just 50,000 kilometers. That's closer than Mars's outer moon Deimos. One stronger outburst at the wrong moment, and the trajectory can tip into direct impact.
Where 0 implies the rank of a natural object, and 10 refers to a technological object that could be a threat to Earth, to humanity. Right now I give it a 4
Avi Loeb is the Harvard astrophysicist who has been warning about technological objects for years. He has made his own scale to measure cases like this. On the Loeb scale, 0 means natural rock and 10 means proven technology. He rated 3I Atlas at a 4 out of 10. If a Harvard astrophysicist is openly telling you there is a 40% chance this thing is technological and sent by aliens, and NASA still is not admitting that there is a threat, something fishy is definitely going on.
There is certainly, almost with a 100% probability, that there is some alien life out there.
Definitely.
Even amateurs saw the weirdness. Photos showed the tail splitting into 3 green beams. Long exposures revealed the beams pulsing in sync with the 17-minute cycle. At times, they even seemed to aim at Mars. A natural comet doesn't aim like that. Scientists also pinged this object. To be exact, it was NASA's Goldstone Deep Space Network that quietly pinged 3I Atlas. The results were classified, but insiders leaked that what they found was unlike any echo they have ever recorded. Normally, comets scatter radar. They are fluffy ice and dust. You get fuzzy, weak returns. This thing has hard metallic echoes. Analysts calculated that there is a metallic core weighing 10 billion tons. Another shocking thing is that the European Space Agency's Mars Express picked up 3 glints in orbit around Mars. At first, they dismissed them as cosmic rays, but then they reappeared. 3 consecutive orbits in the same places in the same triangular formation. So either Mars Express magically glitched 3 times in a row, or 3I Atlas just dropped scout probes. You need to know that if a comet comes with an escort formation, it's not a comet. That's what Avi Loeb is trying to prove right now. By the end of August, it became obvious that NASA is now treating 3I Atlas like a threat. Normally, the Mars Reconnaissance Orbiter scans canyons and craters, but now it is staring straight at 3I Atlas. Maven switched over to ultraviolet, locked in on the same target. ESA's Trace Gas Orbiter and the UAE's Hope probe got new orders too. And even Lucy and Juno, which are way out by Jupiter, were checked to see if they could track it. It feels like 3I Atlas is under surveillance, and NASA is building a net around this thing. So, if they have put a perimeter of eyes around 3I Atlas, what do we actually do about it? People keep asking if we should intercept. But the problem is, we don't have the speed.
From Earth, we cannot launch a rocket that would reach it or intercept it.
At closest swing, this thing is moving around 98 kilometers per second in Earth's frame near perihelion. There is not a launcher on the pad or in the catalog that can go from 0 to that chase. That's why the only workable idea on the table doesn't start from Earth at all. It starts way out by Jupiter. Avi Loeb suggested a pivot with Juno in March 2026.
And if instead of giving it a push into Jupiter, we give it a push away from Jupiter, I wrote a paper suggesting that it could actually, depending on the amount of fuel, get very close to the path of 3I Atlas.
You change Juno's endgame, push it away from its disposal arc, trim toward the 3I Atlas track, and accept a mid-range look measured in tens of millions of kilometers. And before you roll your eyes at that distance, remember that tens of millions out there beat hundreds of millions from home. It's still new angles, new spectra, new timing. The idea made it far enough that a member of Congress sent a letter to NASA asking for a serious look.
And a day after I wrote this paper, I had a phone call from Congresswoman Anna Paulina Luna, who asked me for an update about 3I Atlas. And then when I told her about this opportunity with Juno, she volunteered to write a letter to the head of NASA.
Will it happen? No one knows for sure. But when politicians write letters, it means it's a serious matter that needs to be considered. So what about deflection off Mars? People love to jump straight to the word nuclear. At roughly 57 kilometers per second relative to Mars during that critical window, you do not nudge anything. A standoff burst changes the surface chemistry, strips some dust, ionizes local gas, and then the main body keeps going with nearly the same momentum because the mass is on the order of billions of tons. Hit it head on with a kinetic projectile, and you trade one bullet for a shotgun cloud. That's actually worse for the orbiters and rovers, because small, fast junk multiplies the kill paths. If this object decides to aim low, the window where anyone on our side saves Mars is narrow and the tools are short. So what are the agencies doing right now? They are not sleeping, that's for sure. They are building models like their jobs depend on it, because they do. Those models chew on dust loading in the Martian atmosphere, debris fields in orbit if anything sheds mass, temporary ionization layers that can cook radios for a few minutes in the wrong place, communications blackouts when charged particles spike, and power surges on high-gain antennas that are pointed through the tail. They're testing safe mode triggers for Mars Reconnaissance Orbiter, MAVEN, ExoMars Trace Gas Orbiter, the UAE's Hope, Odyssey, Mars Express, Perseverance, Curiosity, and whatever helicopter hardware still hops. Yes, there are spreadsheets you will never see. They have sigma thresholds across the top and magnetic anomalies down the side. Now, let's do a quick reality check on the watch list, because this matters. JWST already pulled spectra. Hubble got high-resolution frames back in July. Gemini South logged multi-band images on the 27th of August that you have probably seen reposted 100 times. MAVEN's RUVS can pick out ultraviolet lines from the coma, Hope's EMIS does the same trick from a different vantage, Mars Express brings SPICAM and Omega to the table, ExoMars TGO brings Nomad. These are chemistry meters, temperature profilers, density probes, and timekeepers. They tell you whether a brightening is a natural outburst or a controlled plume. That difference is everything. The chemistry keeps poking the same bruise. Cyanide is fine. That shows up in comets. What isn't fine is how often carbon dioxide is dominating water in the coma this early and this strongly. And the metals like nickel and iron are appearing earlier than the solar distance would suggest.
In comets, we usually find both nickel and iron. In this case, we don't. So how is that possible?
If you are trying to steer without a tank, you pick a propellant that flashes off on command and a heat source that doesn't care whether Sun Island. We are not saying that there is a reactor under the ice. We are just telling you that the spectra seem like someone taught carbon dioxide to act like a control fluid. The most disturbing part of all this is that we are not being updated enough. They say that it's not an Earth threat, and that's true for the main body. But if 3I Atlas hits Mars hard enough, ejecta can leave Mars about 5 kilometers per second.
Either itself maneuver or send mini probes that will intercept the Earth. So in that case, the second case, we might see activity a few months later from objects that arrive at the Earth's atmosphere.
Once those fragments are in solar orbit, some of them eventually cross our track years, or even a decade later. Most will be dust and will burn up. Some will be pebbles. A few could be big enough to make you pay attention. This is not the apocalypse. It is, however, the kind of thing that shows up in a serious risk table for satellites and power systems if a dense stream intersects our orbit at the wrong time. Space is a long game. Before we even think about intercepting it, our main concern should be understanding and knowing more about this object.
You know, if we are dealing with a superhuman intelligence, there might be things we simply cannot comprehend, that they know about the physical reality and they know how to manipulate it in ways that we can't.
The triangle over Mars is the conversation nobody in public wants to have. It is either a repeatable imaging artifact. There are 3 small bodies moving in tight formation, like survey drones, checking orbits, sniffing atmospheres, probing communications latency. If the 17-minute pulses are real control signals and not some weird outgassing math, the next clear sign will arrive right before the closest part of the Mars crossing. A phase jump or a tempo change in that cadence would mean the object is shifting its aim. Models show a deliberate delta-V impulse during the September 19 to 30 window that drives the closest approach below 50,000 kilometers, well inside Deimos's orbit. Once the comet is that close, Mars's gravity becomes an active player. One more timed push and the path can flip from miss to impact. That is the geometry everyone is simulating in private. Proof that this is intentional rather than natural requires more than an anecdote. First, independent teams must measure repeatable maneuvers that cannot be explained by volatile physics. Those maneuvers need to be statistically robust and cross-checked by different observatories. Second, materials that do not fit comet chemistry must appear in multiple datasets. Radar tomography resolving sharp planes or layered structure, spectral lines inconsistent with typical meteoritic minerals, or metallic signatures with unusually high radar albedo. Third, release companions must be tracked for days with consistent station keeping and delta-V profiles. One of these items raises a red flag. 2 ends the argument for most skeptics. 3 forces a rewrite of everything we teach undergraduates. Engineers are grinding through the contingencies now. They are writing go divided by no-go rules for pointing delicate detectors near an electrified tail, and they are tuning safe mode thresholds so a single static spike doesn't send a mission into an unrecoverable state. Ground station schedules are being reshuffled to cover critical handoffs when Mars passes behind the Sun for Earth-based views. Communications geometry matters as much as optics. The so what here is straightforward. If 3I Atlas is natural, it is a once-in-a-lifetime lab for interstellar ices and ancient galaxy chemistry. It explains odd tail geometry, carbon dioxide dominance, and unexpected metal release. If it is not natural, it is a guided vehicle executing small plane changes by venting mass, sublimated exhaust used as microthrusters over a long time. That is the exact propulsion method a low-mass, low-fuel probe would use after a multi-millennia cruise. Both possibilities rewrite textbooks. Now, intercept talk is active in quiet channels. Back-of-envelope trajectories show a private fund interceptor might get a mid-range look by late 2026 for roughly $500 million. Catching an object with an instantaneous speed vector of tens of kilometers per second relative to local frames is brutal with late notice. The practical near-term strategy is squeezing every photon from the fleet already in place. Mars orbiters, sun-pointed probes, Hubble, JWST, Gemini, Parker, and the Jupiter assets that can be retapped.
We don't see a big cometary tail that would require much more material, including ices. It may not be ice, it may be just the surface being eroded during the journey that it had before.
Coordinated, honest cross-comparison of instrument data is the high-value, low-regret play. From a public watchlist perspective, track the data signatures. A phase reset of the 17-minute cycle during the late September corridor is the single most telling event. A sustained reduction in projected miss distance under 100,000 kilometers without a corresponding natural outburst is another. This is not hysteria, it is due diligence. The evidence set includes non-gravitational accelerations, a tail that misbehaves by textbook standards, early metal signatures, carbon dioxide dominating water, and a timed cadence that keeps time like a metronome. There is a triangular formation above Mars that resists simple artifact explanations. Spacecraft have been retasked. Juno, as a mid-range observer, is on the table. Parker is ready for perihelion watching. The official line remains calm because calm stabilizes markets and buys analysis time. Operationally, interception only makes sense if it yields learning without multiplying risk. Trying to shove a multi-billion-ton object off course with kinetic strikes or standoff nuclear devices is likely to fragment mass into many deadly pieces, which is worse for orbiters and surface assets. The immediate rational posture is surveillance, risk mitigation for Mars assets, and coordinated international data sharing. What do you think? Tell us your opinion in the comments below. And if you want more updates about this, make sure to subscribe to our channel. Goodbye for now!